Right, question number 2 says the weekly cost K of rented rooms was recorded for 100 students living in an they're living in an what? In an area. Okay, so you're given the amounts in clusters from 0, I would say in kwacha, from 0 to 4 kwacha, from 4 to 10 kwacha, from 10 to 15, and from 10, from 15 to 20, from 20 to 25, and 25 to 30. So this is the range, okay? So these were weekly costs for the room. So others were charging 4 kwacha per week, just like that. So it is said that there are 100 in total. So you had about those who were within the range of 0 to 4 kwacha 3. That's the frequency, and from 4 to 10, that's a 17, and 15 to 20, 31, and 25 to 36. Okay, so the question is, can you construct the cumulative frequency table? So to construct the cumulative frequency table, I think I said that, or I'm saying, I think a red marker can do well, right?
Okay.
A cumulative frequency table. So just from here, what you do when you're accumulating frequencies, you start with 3 here, then you add 3 plus 17 is 20, right? Like you're adding, you're accumulating. So 20 plus 24, it should be 44, right? And 44 plus 31, it should be, what is 34? Or 44 plus 75. 75, and from 75 plus 19, what do you get?
94.
94, and the 94 plus 6, you get 100. Okay, so basically when you sum up all the frequencies, when you're coming up with the cumulative frequency, when you accumulate the frequencies, you end up with the total frequency. Okay, you're told that these students were 100 in total, so that's how you get that 100. So this is how you make a frequency table. There is nothing much. Yeah, that's why it's just a 2 months.
So when I'm asked to do a cumulative frequency table, it's just a continuation on the other side of the table I already
yes
have.
it's just a continuation, because you're summing up, you're basically summing up the frequencies.
Just summing up the frequencies on the other side.
Yes, you need this class is needed, also the frequency is needed, so you're just in short creating another column for the same.
Okay,
good.
Yes, I'm good.
So in case the question is rephrased as relative cumulative frequency or relative frequency, let's start from relative frequency. If the question is relative frequency, what relative frequency means is that you divide each frequency by the total frequency. Okay, so frequency divided by the total frequency gives you the relative frequency. You got that?
Please come again.
You divide each frequency divided by the total frequency. That is how you come up with the relative frequency. Okay, relative frequency. Okay, so if you're asking, can you come up with a relative frequency table? Relative frequency table shall be found by starting dividing all the frequencies, individual score point, by the total frequency, which is 100. So you shall say 3 divided by 100. What do you get? Relative frequency. What do you get? 3 divided by 100 should be able to get 0.03, and the 17 divided by 100 should be able to get 0.17, and the 0.2 what? 24, and 0.39, 0.19, and 0.06. You got that? So basically, you're just dividing each frequency by what? By 100. That's a relative what? Frequency. You got that?
Yes.
That is a relative frequency. But again, the question can be relative cumulative frequency. That's a different one. So I'm saying relative relative cumulative frequency. Okay, relative cumulative frequency. This is another one. So relative cumulative frequency, what it means is that you come up with first the relative frequency, come up with the relative frequency, then you accumulate it.
Okay.
Yeah, so you come up with the relative frequency here. The relative frequency RF is 0.03, 0.17, 0.24, 0.31, 0.19, 0.06. Now, the relative cumulative frequency, it simply means that this relative frequency, you accumulate it again, the same way how you were accumulating the frequencies. Got it?
Yes.
You accumulate the relative frequencies. So you say 0.03 divided plus 0, or you start with 0.03, okay? And it says 0.03 plus 0.17, it should be 0.20. Yes, so 0.2 plus 0.24, what do you get?
0.44.
0.44, and 0.44, that will be 0.7 what? 75, right?
Yes.
And 0.75, what we have 0.94, right?
0.94.
And 0.94 plus 0.06, it should give us 1.00.
Yes.
So the take-home message is, when you sum up the relative frequencies, the total sum is 1. They should all sum to 1. Did you get the message? Yes, sir, I got it.
I've got it.
Okay, great. So we can move forward and come up with a histogram, a polygon. So with a histogram, what it means is that you come up with the classes. These classes, you write ranges of the classes from 0 to 4, and from 4 to what? From 4 to 10, from 10 to what? To 15, to 20, to 25, and to what? To 30, like that. Okay. These are your numbers that you have drawn. So how you come up with a histogram, you plot these numbers against the frequency. This side, there will be a frequency, okay? The frequency on the vertical axis, and then on the horizontal axis, you have the classes, the amount. In this respect, you're talking about the class or the amount that these guys were paying, okay?
Okay.
And so you have your frequencies. So we divide in the ranges of the highest goes up to 31. So I think, yes, we can just divide them in the range of 5 so that you don't find a challenge. You can have 5, 10, 15, 20, 25, 30, up to somewhere 35, right? I'm not using a standard scale. I'm sure you're understanding. And so from there, let me use a brown marker for the histogram itself. So you plot this class from 0 to 4 against the frequency, and the frequency is 3. 3 is somewhere here. So this is how you plot, okay? And then you come up from 4 to 10. What is the frequency? It's 17. 17 is between 15 and 20. So you move between 15 and 20, somewhere there next to 20, like that, okay?
Okay.
And from 10 to 15, what's the frequency? Is 24. 24 is just near 25, and like that. And from 15 to 20, we've got a 31. So this is 15 to 20. 15 to 20, we have 31, right?
Yes.
Okay. And from 20 to 25, we have 19. And 19 is somewhere here close to 20, closer to 20, something very closer to 20, like that. Oh, let's try to draw it properly. You see, it is somewhere here. Okay. And the last one is 6. 6 is just above 5, just above 5. like that. So this is the frequency. Okay. This is called a histogram for you. If you want, you can even label it. Raising. Okay. I did draw it like this. Okay. So here is the thing. So you can even label it like this. This is your histogram. Okay. It is actually your histogram, just like that. Okay. This is called a histogram. A bar chart is not joined like this. The bars are not joined. That's the only difference. But with a histogram, they're joined together like that. As you can see, the bars are really joined. But all of them, the bar chart and the histogram, are marked against the frequency. Okay?
Okay.
Yeah. We're good to go?
Yes, please.
Okay. If you're good, let me just answer the next question now, which is and I'll use the black marker. Which marker? Blue. I want it to be different. Let me try to use black and see how it comes out. Now, with a polygon. Now, when they say polygram, in short, they derive it from a polygon. So how you draw a polygram? You come here in the middle of the class, right? Find the midpoint of the class. And it say 0 plus 4 divided by 2. It should be 2, right? Somewhere here. Okay. For this class, first class. So you find that you mark this midpoint, which is 2, against the frequency. So you have a point somewhere here. You got it? And again, you come the class between 4 and 10. 4 plus 10, that's basically 14. Divided by 2 is 7. So somewhere here there is 7. 7 is marked against the frequency, and the frequency is somewhere here, right? That's the frequency, the respective frequency. And you come here, the midpoint, right? 10 plus 15, and divided by 2, you have 12.5. 12.5 is marked against the frequency here, which is 24. And you have 15 to 20 divided by 2. That should be 22.5, right? Is it? 15 plus 20? No. 15 plus 20 is 35. 35 divided by 2, it should be 17.5, right? 17.5. 17.5 is marked against the frequency there. And again, you come here, the midpoint against the frequency, the midpoint against the frequency. Then you join these points, okay? You're joining them. Regardless of the shape, because this is a polygon. You've seen what we have come up with. Are you able to see it in black?
Yes, I can see.
Yeah, this is what you call a polygram, okay? A polygram is basically the midpoint of the class marked against the frequency that will give you a polygram. You good?
Okay, I get it.
Are you fine? Okay.
Yes, I'm fine.
If you're fine, then we can move on to calculating the mean. Now, this data is called a grouped data. It's different from the one that we had last time. The data that we had last time was summation of x values divided by n. That is how we're finding the mean, right? And that is called ungrouped data. So when data is scattered like that, you just sum all the individual scores and you divide by the total frequency, okay? By how many they are, which is a sample size. Now, when you are dealing with grouped data, the story is a little bit different. So you get to find the midpoints. First of all, find the what? The midpoints. Let me produce a column for the midpoints here. The midpoint. Okay. So how do you find the midpoint? Just add the lower class boundary added to the upper class boundary and divided by 2. You take the average of the upper class boundary and the lower class boundary. Then that gives you the midpoint. Okay. So you shall say 0 plus 4 divided by 4, or 0 plus 4 divided by 2. You should get a 2, right? And
Yes.
10 plus 20, that gives you 7, right? 10 plus 4 gives you 14. 14 divided by 2 is 7. And 10 plus 15 gives you what? 35 divided by 2 is 25 divided by 2, that is 12.5. And 15 plus 20 is 35 divided by 2 gives us 17.5. And you have 20 plus 25, which is 45 divided by 2. That gives us 22.5. And then you have 25 plus 30, that gives us 55 divided by 2. We have 27.5, yeah? Okay, 27.5. These are what we call the midpoint. The midpoint. So now, to find the mean is found as the summation of the frequency times the midpoint. Okay, let me just name now the midpoint, x. Summation of f of x, where your x is the midpoint, then divided by the total frequency. Okay, this is your x bar, your mean, right? Did you get that?
Yes.
This formula means that you will be summing up. Okay, you will be adding. You're going to be adding the product. Let's start with the first one. The x value, the midpoint is 2 times the 3, the frequency, plus again 7 times what? 17 plus 12.5 times what? Times the 24 plus what else? 17.5 times 31 plus what is that? 22.5 times 19 plus 27.5 times 6. Like that. You sum everything, you divide by the total frequency, which is 100. Okay, you sum everything. So you'll be multiplying this times that, plus that times that, plus that times that, plus that times that, plus that times that, and divided by what? By 100. Whatever you get is what is called the mean. Okay, you cool?
Yes, I'm okay.
You're okay? That is how you find the mean. So after that, how do you find the standard deviation? The other question is asking us about how to find the standard deviation. So the standard deviation AD shall be given as the square root of summation of frequency times x, frequency times x minus x bar, you square that, divided by the total frequency, which is same as n. Okay, see now that last time we said standard deviation is the summation of x minus what? X bar squared divided by n minus 1. This is when you're dealing with ungrouped data, okay? You use that as a formula. But this data that we have right now is a grouped data. Therefore, the standard deviation shall be given as the summation of f, which is the frequency times x minus x bar. You square that and divide by the total frequency, then you square root everything. Did you get it?
Yes, I do.
Yeah. If you got that, then the question is, what is your x now? What is this x? Okay, I'm demonstrating some understanding check. So this is how you arrange. You start with the frequency first. So you say 3 times the x value is what? 2, right? The first x is 2 minus the mean that you're going to find. Then you square that plus, you're following, right? So the frequency first. The next frequency is 17 times 7 minus the mean, and you square that plus 24. So you begin by the frequency first. Then you write the middle point, 12.5 minus x bar. You square that plus 31, right? Times 17.5 minus x bar. You square that. You keep on adding and adding everything. Then you should be fine. Okay? When you're done doing this, you will sum everything and divide by the total frequency, which is 100. Then you square root your answer. You square root your answer. That's standard deviation. Okay?
Okay.
So say 3 times 2 minus x bar, of which x bar is the mean. I've already shown you how we find the x bar. You're good?
Yes.
You ask us questions where you're not clear. It's very necessary that you always ask us the questions. Yeah, it's always very, very necessary. Okay, so these are the solutions. I think I sent you these solutions, right? Yeah, I sent you these solutions. Summation of f of x, summation of f of x, like that, you divide by that, that's the mean, then you sum up that and that. Okay? All right. Then you come up with this one now. This one is the...
You're not sharing your screen. Okay, now I can see.
Okay. Here's the other question now. The other question is, consider the following table containing data of students who took statistics from those who did not take statistics. Just like the example we had last time, you remember in class, under statistics, we have total number of male, 229, total number of female, 210, and all of them in total, 439. Others took statistics, others did not take statistics. Got it?
Yes.
There is a contingent table. So now, the question is, our question says, can you find the probability of those who took statistics? Those who took what? Statistics. What is the probability of those who took statistics? So just come here in the contingent table, you check. The people who took statistics, just those who took statistics, right? How many are they, those who took statistics? The 160 divided by 430, what? 39. Okay? Just like that, you divide, you find a fraction. You good?
Yes, I am.
Can you find the probability of female who did not take statistics? Female who did not take statistics. So you come to the total number of female. How many females do we have? The total number of female who did not take statistics. Female that did not take statistics are 134. Divide that by the total frequency. Okay, total number of students, how many there are? There are 439. You got that, right? So everything is out of that because this is the total sum of, these people are just put together in a class. So as a sample size, so therefore you will not have to. Okay, you're fine?
Yes, I'm okay.
Okay, if you're okay, the students who took statistics, now you just want the total number of students who took statistics. Oh, the first question was males who took statistics.
Males who took statistics.
Yes, so you needed males who took statistics only. So it was going to be 84 over 439. You got that, right?
Yes.
That's for males. Now, when you say total number of those who took statistics, that's when you say you add all these female and male. Okay. Over 439. Okay.
Yes.
And for the next question is the students who took statistics, that is it. The marginal probability of female students. The marginal probability of female students, that is same as the probability of female students. So how many female students do we have? There are how many
Did
in
not
total?
take statistics 134.
Sorry?
It's saying female students who did not take stats.
Oh, female students who didn't take stats. Oh, where are you? I'm on question number 4. The marginal probability of female students.
We're doing the
Have I
marginal
lost?
probability of female students. Okay.
Yes. The marginal probability of female students. The female students, there are how many? There are 210. Divide that by 439, and then you should be fine, okay?
Okay.
Yeah, so this is what is there. Then the female student who didn't take statistics, it should be 134 all over 439, then it should be fine, okay?
Okay.
I think you're fine now on how we read the contingent table, then you should be fine. The question is, how many words? Oh, can you find the number of permutations of the word accommodation? The number of permutations of the word accommodation. So now, the word accommodation, in short, in what ways can you combine these words? So you just count the number of letters in the word accommodation, then the factorial thereof, okay? Did you get that? So you will count how many letters are in accommodation. 1, 2.
Yes.
There are how many? How many letters are in accommodation, in the word accommodation? Hello, how many letters are in the word accommodation? Can you hear me? Are you able to hear me? Hello?
Hi.
I'm saying how many letters are in the word accommodation?
There are 12.
There are 12. So the permutation is 12 factorial. I'm sure you know how to do
Yes.
factorial, right?
Yes, I do.
Yeah, so just say 12, shift the upper left there, papa, factorial. It should come clear. There is a button on a casual calculator, this one. Then on the top, no, not this one. There is that button which is written as x to the power 1 like this. Then on top, it has got this symbol. So you just shift, you press that button, then you should be fine. Okay? It's giant number, right?
Yes.
Any
So
question?
I'm getting 479 million.
79 million.
479.
470.
When I do 12 factor. I don't know. What are you getting?
Unless I check. I don't have a calculator where I am, so I can't do factorial.
Oh, okay. When I do my 12 factor, it's giving me 479 million.
Okay. That same one is
1,600.
Oh, okay, great. That same one is just 12 factorial. That's the solution. Okay.
Oh, okay.
Okay. Now, on question number 4, can you define the random sample? Anyways, I think this is boring. You even know that. Hello.
Hi.
Yeah, the random sample. What is a random sample? And these things, I think we read them in the books, isn't it?
Yes.
You know, a random sample, right? You already know a random sample and inferential statistics. This is where you draw conclusions, right? You draw conclusion or make judgments, descriptive statistics. This is where you describe characters, just like that. So I think you can easily follow through this and you should be fine. Oh, I want to do this question which requires someone. Okay. Is this question the same as the question that would? There's no way where it is asking us to do percentiles. There's no question for percentiles or anything. It's not. It's not asking us to do some percentiles.
No, I don't think so.
Yeah, this one is an example actually. Question number 6 and 7 is an example. If you have been following in one of your lectures that we did, it's an example and the answers are given. It was just highlighted and pasted, just like that. So it should be there something like that, number 4 or something. But is in one of those lectures that you sent me, the 2 were examples.
Question 6 and question 7.
Yeah, they just check through there. They even have answers and everything. It's just there. Let me comment on question number 5. Okay, 7. Question number 7. Jasmine owns 5 stocks. The probability that each stock will rise in price is 0.6. What is the probability that? Okay. So now, I have been very fast. I don't know if you've been able to get me. I think I've been, but I think I have been fast, right? Or I've been okay.
Today?
Eh.
No, I'm grasping what you're saying.
Oh, okay. Let's have this one now. With this one, this is where I deal with the probability distributions. With this one is coming from binomial probability distribution. That same one you did in business mathematics and statistics, if you remember something. In business math and statistics, there was that part where you are looking at probability distributions. To be specific, we looked at binomial probability distribution. Okay, let me just contextualize so that you understand. What happens is that when you're calculating probability, there are those experiments. Like, for example, let me start from a coin, right? If you throw a coin once, let me ask you, what's the probability that it will give you a head? Obviously, you can even tell us that it's 1/2, right? That's the probability of us getting a head from a coin. So now we ask you the question, what if you throw this same coin a specified number of times? Let's say 100 times. What is the probability that you get 10 heads? That is a lot of work, right? You can manage to do that. Yeah, that work can be a lot. So if you are to calculate the probability of getting a head when you throw a coin such a number of times, like 100 times, you cannot really manage to do it one by one. So binomial probability distribution seeks to give us the solutions on those probabilities for situations where, number 1, the probability of success is fixed throughout the experiment. So that is to say, even if you try out this experiment several times, the probability of an independent trial shall be the same. Okay, the probability of an independent trial. For example, the probability of throwing whenever you throw a coin, you have the probability of 0.5 of getting a head, right? If you're looking for heads, you have 0.5. Regardless of the number of times you can throw this coin, at each time you throw it, if you regard this as just an independent trial, right? Just as one trial, it will always give you that probability. So when you throw it the 10th time, it will still be 0.5. When you throw it the 30th time, it will still give you the probability of 0.5. So in short, the probability of success, what is success? Success is finding what you want in the probability. Remember, if you're asked to find a head from a coin, so whenever you find a head, that is your success, okay? If you get a tail, then that's your failure. Do you understand that? If you get
Yes.
if you get what you're not looking, then you have failed. Then when you get what you want, you have succeeded. So the probability of success in each independent trial, it is fixed. That's one of the characteristics of binomial probability. It's the same. And again, the other one is that there are only two outcomes, a success and a failure. So this is where you have the probabilities such that you just, the experiment that you're doing just has two outcomes, just two. You see, for example, a coin, it can either be a head or a tail, okay? It is just two outcomes only, yeah. So this is what is there. Maybe you're dealing with the example, you're studying the pens, the probability of picking maybe a defective pen. So when you group the pens, you can only have defective pens or non-defective pens, like normal pens, good pens. So that's what is there. So in short, the probability of success and the probability of failure sums up all. Get that?
Okay.
Yes. So what is there is when you're calculating the binomial probability distribution, you will say that the probability of x, the random variable, shall be equal to the combination of, I don't know if it's you, I was teaching about the combinations. I can't remember exactly. Did I talk about combinations to you? Yes, I did. Like how to press this one. This same part, let me label it blue. This one on your calculator.
No.
We didn't. Like, okay. The combinations, when you go on your calculator, this is a number. It will be NCR. So let's NCX. There is that button on your calculator that has got this NCR. Okay, that's for the combinations. So you press the number, for example, 6 combinations of 2 shall be pressed as you press the 6, then you press this button, then you press 2. It will write something like this on your calculator. Can you try it?
I have.
You have, what's the combination? What is the 6 combinations of 2?
So it's supposed to be, I press 6, second function, then I press the button that has NCR.
Then you press 2.
And then I press 2.
Yeah, it should write something like this. Then you press equals. Right?
I'm getting 15.
Or 15? Okay, it's fine. So that's how you do the combinations in short. That's how you deal with this first part. So this first part, just get it that is a combination, but this one is fixed. It's the probability of success in each independent trial. Then this one is 1 minus that probability. Then N is the sample size, the number of trials that you have tried. And the X is the probability of success that you are looking for. So for example, let me create a question before we come to this question. Let's say you have coins, right? You have a coin. And then the question is, what is the probability that you get 3 heads when you throw this coin 20 times? That is the question. Remember now, in a coin, there are only two outcomes, right? Head or tail. So the question is, what is the probability that we get the 3 heads? Okay, so your N shall be what? 20, the number of trials that you have tried that experiment. Then your X shall be what? Shall be 3. Then your P is the probability of succeeding, the probability of getting ahead when you try to throw the coin once, in short. That's the probability of success in one independent trial. So what is the probability of getting ahead from a coin when you throw it once? You get 0.5.
0.5.
1 over 2, which is same as 0.5. So these are parameters that we've gotten. See how we fuse them into the formula. Okay, so this is how you do it. So you say 20 combinations, your X is 3, right? Times the probability of success is 0.5 to the power X is what? 3 times 1 minus P, which is same as 0.5, right? Okay, 1 minus 0.5 is 0.5 again. Then to the power 20 minus 3. Look at that one. Have you seen how you set up? Yes. You can find the answer. Can you do 20 combinations of 3?
That's 1,140.
1,140 times 0.5 to the power 3.
0.5 to the power 3 is 0.125.
0.125 times 0.5 to the power 17.
0.5 to the power 7.
0.5 to the power 17, not 7. The power 17, 20 minus 20 minus 3, 17.
To the power 17. It's
Yes.
0.00000007629.
Okay. Anyway, so when you multiply everything now, these 3, what do you get as the probability? What is the probability?
Just a minute. It's 0.001087,188.
Okay, so that one is the answer. All your answers, I said they should not be above 1 and they should not be negatives, right?
Yes.
Yes. So that's what we said under probabilities. I think you have gotten an idea now. We can go straight to our question. So our question is saying, Jasmine owns 5 stocks, right? So the total number of stocks is what? 5. So the probability that each stock will rise in price is 0.06. So our P is what? 0.6, right? 0.6. Then our 1 minus P will be what? 1 minus 0.6 will be 0.4, right?
0.4.
Then our N, the number of stocks that we have there, 5, isn't it?
Yes.
Yeah, the number of stocks that we have are 5. Then now, here is the question. What is the question? Can you find the probability that 3 out of 5 will rise in the price? So in short, we are asking the probability that X is equal to what? Is equal to 3. You get it, eh? 3 out of 5. Like, what is the probability that 3 stocks will rise in price? Given that each stock has a probability of 0.6. So this is an independent trial. Like, one of them has got the probability of 0.6. So it is fixed, it's constant, like that. You got it? So we start computing into our formula. 5
so our
combinations
P is 0.6, right?
Yes.
And then what is our x?
Our x is
0.4?
3.
Is 3. Oh, okay. All
Our
right.
x is 3. What is the probability that 3? So these will be your x's. Your x's will be down the question. Okay. And times the probability of success p is 0.6 to the power 3 times 0.4 to the power 5 minus 3, right? Like that. What do you find? Five combinations of 3.
5 combinations of 3 is 10.
Is what?
10.
10.
Yes, I'm getting 10.
Okay. Then 0.6 times or 0.6 to the power 3.
0.216.
0.216.
216.
And 0.4 to the power 2. 5 minus 3 is 2.
It's 0.4 to the power 2. Our n is 5. Oh yeah, 5 minus 3. 0.4. Giving me 0.16.
0.16, right? It is giving you 0.16, right?
Yes.
When you multiply everything. So that's the probability, okay?
Okay.
Yeah. So the other one is at least 2 will rise in price. Now the word at least means greater or equal to, right? Greater or equal to 2. So when you ask it, at least 2. So what it means that 2 is included, right? When you say at least greater or equal to 2. So it's 2 and above. So what you can do, since we know that all the probabilities, when you sum them, they equal to 1, right? You can just subtract these lower probabilities from 1. So say 1 minus the probability that x is equal to 0, okay, plus the probability that x is equal to what? Is equal to 1. You followed, eh? So there are 5 in total. Okay, so we are asking for the probability of finding 1 and above, isn't it? Or of finding 2 and above. So what you can do from the total sample of 1, you can remove the probability of getting 0 and the probability of finding 1, right? There is a probability that you can get 0, like 0 of stock will rise in price. That probability is there. So that is the one that you are removing. Everything that is lower now, you're removing 0 and you're removing 1. Then the rest will remain, right? I don't know if you're getting this math that we're trying to do. So like the total probability is 1. When you sum, okay, when you sum the probability that x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, to 4, and to what? To 5. When you add them together, they should give you 1. Did you get that, right?
Yes.
So now the question is, what is the probability that you get 2 and above this one? So it just means you can remove these. Since you know that the total is 1. So you can say 1 minus these, then you should remain with these, isn't it? So that's how you do it. So what it means is that now you will calculate for the probability of finding 0, that x will be 0, and the probability that x is 1. You add them together, you subtract them from 1. So 1 minus the combination, let's start with 0. So have 5 combinations of 0. The probability is still the same, to the power 0, right? Times 0.4 to the power 5 plus, right? 5 combinations of 1 times 0.6 to the power 1 times 0.4 to the power 4. Y to the power 4, you know that you are subtracting 5 minus 1. So when you do that, you add this as one number. You calculate this one plus this one. You add them, then you subtract their answer from 1. Then you should be able to get the probability I was talking about. You cool?
Yes, I'm okay.
You can ask me if you need clarity. Very important.
Yeah, I get it.
You get it, eh?
Yeah.
Okay. If that is okay, there is a question at least now, or at most 3. Now, the way the at most simply means less or equal to at most 3. So which means you can get less or equal to what? To 3. So since we have many that is less than 3, we have 0. This includes the probability of 0, 1, 2, and 3 itself, right?
Yeah.
5. So what has remained is just a probability of 4 and what? And 5 itself, isn't it? The probability of finding 4 and 5, isn't it? That's what has remained. So what you can do again, from 1, you can subtract the probability of finding your x equal to 4 plus the probability of finding your x equal to 5. You got it?
Uh-huh.
Yes, when you remove for 4 and 5, you remain with 3 coming down. Because the question is, what's the probability of finding 3 and down? Okay, 3 and less. That's at most. So the way the at most is simply means less or equal. You got that? The formula is still the same. It's only that where there is x, you put 4. Then again, where there is x, you put 5. Then you add them together. You add those answers and you subtract them from 1. You cool?
Uh-huh.
Okay. Exactly 4 will rise. X is 4 now. So n, your n is what? It's still 5. Your n is not changing. 4 now. The probability of 0.6 to the power 4, right? 0.4 to the power what? 1, right? Which is 5 minus 4, 1. You do this, you know how to do it. 5 combinations of 4, 0.6 to the power 4, 0.4 to the power 1. You multiply all the answers and you should be fine. You cool?
What? Okay.
Are you fine?
I'm coming. Yes, I'm okay. Sorry, I'm just a bit distracted. I'm supposed to have the last meeting for the day just now.
Oh, and
Yeah.
so it means you take some time, isn't it? Yes,
Yeah, because I'm not